Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at one of the applications of the L'Hopital's rule, and this is going to be basically dealing the, of course, results of this specific function, a limit of functions which are going to be giving us an indeterminate form of the limit, which is going to be given in terms of course, infinity minus infinity. And we're going to consider this specific example which I've just given on the board. And if we try to evaluate the limit of this specific function using the substitution method from our last discussion, we're going to have this one given in terms of the limit as x tends to 2. So this is going to be given in form of 4 divided by the square of x minus 4. And of course, this is going to be minus the value of 2 minus 2 given as such. So the first section is going to be giving us basically the limit as x tends to 2 given in terms of 4 all over 0. And this, of course, is going to be giving us the second case for the result of a function given in terms of 1 over 0. So these are going to be giving us a result of course, infinity minus infinity given as that one. And we're going to use the application of the L'Hopital's rule, which is going to be assisting us trying to find the various range of derivatives for the subsequent steps and try to see whether that is going to be giving us a different result. Now, in this particular case, we're going to have this one given in form of a rearranged equation, which we can give as the limit of a function as x tends to 2. We're going to have this particular value of course, 4 given in that specific form, and then we're going to have this one given in terms of x plus 2 given as such. So this is going to be all over the result of 2 minus 4. So I've just done a summary, a form of trying to do this specific rearrangement. Now, from our previous discussion, you can realize that this basically section of the denominator for the first factor is going to be a difference of squares of 2 factors, linear factors given in terms of x squared into x minus 2. And therefore, this is going to be considered in case we are going to look at this particular value. This is going to be going to this denominator to this common factor once. So therefore, we're going to have 4 minus. This is going to be going to this specific factor at x plus 2, since it's going to be one of the components of each 2 factors. And therefore, we're going to have it at that specific upper level. So we're going to have that specific equation transformed as such. And if we try to, of course, perform these subsequent steps, then therefore we're going to have this specific equation again transformed into another particular kind of an equation, whereby we're going to have basically this equation given in terms of the limit as x tends to 2 of this particular function is going to be 4 minus, so this is going to be 4 minus 2, which is going to be giving us 2, minus this specific value of x all over x squared minus 4. So we're going to start our evaluation from this specific point, whereby we're going to perform the derivative of this specific function and have it as the limit as x tends to 2. So according to the L'Hopital's rule, we're going to find of course, the first derivative of this specific function, which is going to be giving us a negative. So this is going to be negative 1 basically, all over 2x given as such. So if we consider substitution at this specific point, we're going to see that this is going to be giving us a negative 1 all over 2 into 2 given as such. And this is going to be giving us a negative quarter for the value of the limit. So contrary to the first, of course, result which you have obtained from substitution, which was basically infinity minus infinity, we're going to find different results as per the L'Hopital's rule, which is going to be assisting us trying to evaluate a limit of such a kind of course, functions which are going to yield infinity minus infinity. So this is going to be one of the applications which we are going to use in trying to evaluate such a kind of indeterminate forms. And of course, we have already done a number of videos which we have done for the different types of indeterminate forms for the concept of various limits and how we can, of course, evaluate those ones using the L'Hopital's rule. So kindly check our description boxes for various links of such videos. They are going to be contained in terms of a playlist, and I'd like to request our members to be kindly opening those and check they're going to be containing topics under a similar discussion. So that is it for now, guys. Bye. God bless you. Catch us in our next video.